Okay, so we're going to talk about two very special right triangles. So the first one here that I've got sort of right here, right? You'll notice that the angle in it is pi over 4 or 45 degrees, and that's actually in both corners of that triangle. Okay, and we know that if those are the two angles in that triangle, that the side lengths are going to follow the ratio of these two sides being 1, and then the hypotenuse side needs to be root 2. Okay, we can use this triangle to help us evaluate trig functions for the angle pi over 4. So if you don't have a calculator, okay, you can still go through and work out the sine, the cosine, the tan, as long as you know about this triangle. So there's our angle pi over 4 right there in that corner. Okay, and so if I were to sort of go through and label the sides in relation to that angle, I usually start with my hypotenuse side, right? That's the side that's not touching that right angle at all. Okay. Now remember, I'm looking for the side that's near the pi over 4, because the side that's near pi over 4 is going to be adjacent to the pi over 4. So this side is my adjacent side, and that leaves me with this last side over here being my opposite, right? Remember, it's on the complete opposite side of the triangle relative to that pi over 4. Once I've labeled those three sides, I can use those to help me evaluate the sine, the cosine, and the tangent. So the sine is always which side over what side? Remember? Opposite over hypotenuse. So in this case, my opposite is 1, and my hypotenuse is root 2. Now, if you were on a test, I think you could leave 1 over root 2 as the correct answer. There's no problems with that at all. But some teachers will go through and they don't like that root on the bottom. So if you multiply the top and the bottom by root 2, remember that's just a big fancy 1. If we do that, then we end up with root 2 over 2. And that would also be a correct answer. So if you leave this as your final answer, I think that's correct. But I think also if you left the 1 over root 2 as your final answer, that would also be correct. I don't think it really matters. But just in case you've seen a different value for the sine of pi over 4, hopefully it was either 1 over root 2 or root 2 over 2 if you saw it before. Okay, so the cosine, if we wanted to do that, cosine is always, let's see, adjacent over hypotenuse. So in this case, it would be 1 over root 2 as well. And for the same reason as before, root 2 over 2 would also be a correct answer. So again, either way. And then last but not least, the tan. The tan is always the opposite side over the adjacent side. So in this case, the opposite side is 1, the adjacent side is 1. So the tan would be 1 over 1, which is 1. Okay, so as long as you have that special triangle memorized, it will allow you to work out the trig values for sine, cosine, the tangent for that angle, even without a calculator. Now, this second triangle that I've got here, let's just highlight it for you. You can see what I'm talking about. So this triangle over here, okay, it's actually got two angles, special angles in there, right? So the first is the pi over 6, or the 30 degrees, right? That's what's in that bottom left-hand corner, okay? And in the top right-hand corner, I've got pi over 3, or 60 degrees. So we can use this triangle to work out the sine, the cosine, and the tangent for both of those angles. Now, it's really important that we pay attention to how these sides are labeled, right? So, for example, the root 2, or the 2, is always the hypotenuse side. So that one's usually where I start in terms of labeling the sides of my triangle. Now the root 3 here, right, that has to be on the side that's right next to the pi over 6, okay, and directly opposite from the pi over 3, the orange one, okay. Then the 1, it needs to be adjacent to the pi over 6 and opposite from the pi over, oh, I said that backwards. it has to be adjacent to the pi over 3 or 60 degrees, the orange one, or it has to be opposite from the pi over 6 or 30 degrees. Okay, so it might take some practice to kind of make sure that you've got that labeled properly. In terms of actually memorizing it, if it helps you, I always personally remember that this 3 is always completely opposite this 3. So the root 3 is always opposite the pi over 3. And then to sort of check my work, I always remember that 2 and 3 are kind of surrounding the 6 because 2 times 3 gives you 6. I don't know if that helps you remember or not, but just make sure that you're labeling your sides properly, or otherwise you won't get the right values here for these trig values. So if we're talking about pi over 6, right, that's that green one, okay, we better label our sides accordingly. So remember this 2 side, that's our hypotenuse. It's always sort of across from that right angle. Now, relative to that pi over 6, that root 3 is close by. They're nearby. So this is my adjacent side. This side is adjacent to that angle pi over 6. And this 1 is opposite, complete opposite sides of the triangle to that pi over 6. And once I've labeled those sides, I can use those to work out the sine, the cosine, and the tan. So sine is going to be opposite over hypotenuse, which in this case is 1 over 2. The cosine is adjacent over hypotenuse, which is root 3 over 2. And the tan is opposite over adjacent, which in this case is 1 over root 3. Now, if you left your answer as 1 over root 3, I think that's totally fine. No problems with that at all. Some teachers, rather than having a root on the bottom, they might take this 1 over root 3 and multiply it by root 3 on the top and the bottom. So we end up with root 3 and just a 3 on the bottom. So that would also be a correct answer. Again, I don't think it really much matters which one you use. This one is a correct answer, and this one is a correct answer. So whichever one you have memorized or you want to get to, that works for me. Now, if we wanted to talk about working out the sine, the cosine, the tan for pi over 3, which is the orange angle there, okay, then we're going to have to go through and relabel our sides, right? Oops, it's jumping around on me again. So the hypotenuse side is still the same, right? Because the hypotenuse side is still kind of directly across from that right angle. So that part isn't changing. But if I'm looking for the side that's adjacent to that orange angle, or the line that sort of is next to that orange angle, this 1 is now going to become the adjacent angle relative to that pi over 3. And the root 3 on this side is the opposite. It's directly on the opposite side of the triangle from that orange root, pi over 3. So if I want to use those to plug in here, right, the sine of pi over 3 is always opposite over hypotenuse, which in this case, relative to pi over 3, is root 3 over 2. Oh no, yes, root 3 over 2. I did that right, okay. Now the cosine is adjacent over hypotenuse. So in this case, for the orange angle, I would have 1 over 2. Okay. And then for the tan, it's still opposite over adjacent. So in this case, my opposite is root 3 and my adjacent is 1. So root 3 over 1 just gives me root 3. Okay. So we can use these special triangles to be able to help us work out some common trig values for some common angles. And it allows you to be able to do it without a calculator. So it's really important that you have these memorized. There are other ways to be able to work out the sine, the cosine, and the tan for these 3 angles. In particular, I'm thinking about the unit circle. So if that's something you're more comfortable with, you can use that instead. Or if you prefer that method, that's fine. But this is one way to do it, to be able to get sort of the exact values for particular angles, these 3 special angles. You can use these 2 special triangles.